Hello, everybody. Welcome back. It's Mo again. In this lecture, what we're going to be looking into is subnetting. What is subnetting? How do I subnet? How do I use them? Why do I need subnetting? Ask yourself, and that's what we're going to be getting into in this lecture. For example, when it comes to networks, there's two types of networks. I have a classful network, and then I have something called a classless network. Now, what does that really mean? Classful, which means I am following the subnet mask rules. Classless, which means I am not. So classless is actually subnetting. I'm actually subnetting. Classful, which means no subnetting. So I am not actually subnetting with this structure over here. Now, why would I need to subnet? Now, think about it this way. What is a classful network? Let's say starting with a class C, 192.168.100.0/24. What does that mean? Well, 100.0 is my network ID, right? And 100.1 is my first host, and 100.254 is the last host, and the broadcast is 100.255. My subnet mask is 3255.0. That means my network as 100.0, I got 254 hosts. That's a lot. There's no way you'll be putting 254 hosts on the same network. That's too much traffic. That's too much broadcast, and that's not good for security. When I say I'm subnetting, I'm going to be breaking down my network into smaller networks without using other networks. You're going to tell me, well, okay, Mo, I have 192.168.100.0 for one department. Then I'll put 110.0 for another department, then 120.0 for another department, then 130.0 for another department. You could do that, but you still get 254 hosts, which means any broadcast that gets transmitted is going to look for all those hosts. You're going to be slowing down your network, and that's not good for security. So I'm going to be breaking down my network into smaller networks. Now, why would I do that? It could be because I want to have my printers on one network. I want to have my actual cameras on one network. I want to have my laptops and desktops on another network. I want to have my phones on another network. Or I could say, I want every department to be on a different network with the hosts that I'm looking for. I'm not looking for 254 hosts. Okay. So, for example, watch this. Now, remember, there's one thing that we need to understand: the 128, the 64, the 32, 16, 8, 4, 2, 1. See that? I always have to keep that in mind. First, we're starting to subnet a Class C network. So let's say 192.168.100.0/24. And I'm going to come up with a random number. I'm going to say I am looking for 8 networks. Okay. Or 8 what? Yes, subnets. So I'm looking for 8 different networks or 8 different subnets out of this network over here. So when I subnet, it's a classless network. That means I am not following the subnet mask rules. For example, watch this. So 192.168, right? Dot 100.0. My subnet mask is 255.255.255.0. I'm going to convert that to what? To binary. So remember, if I want to convert to binary, how do I get a 255? 1111111. All right. So watch this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. How do I get a zero? I put all the bits as zero. See that? Just like that. That's why I get slash 24. I have 24 bits turned on for a class C. So if I have it like this, my first host is 1, my last host is 254. Well, I'm looking for 8 networks. Let's say it's 8 different departments in a company: tech, sales, HR, marketing, QA, and so on. Or 8 different types of networks, such as one is laptops and desktops, and one is printers, one is cameras, one is phones, and just like that. That's how I calculate how many networks I need. Now, I also need to calculate how many hosts I need per network. Well, let's say we do it this way. So I'm going to go ahead and do the following. How do you subnet? Well, think about it this way. I am looking for 8 networks. My formula is this: 2 to the power of n is equal or greater than the number of, watch this, nets that I'm looking for. Now, what is n? N is the number of the bits that I'm going to be borrowing from the host portion. Now, remember, this is a class C. I cannot mess around with the first 3 octets. I only can mess around with the host octet. So whenever you're doing subnetting, you are messing around with the host portion. You are borrowing bits from the host portion. That's where you're actually getting this from. So for example, what is the value of this? 128, 64, 32, 16, 8, 4, 2, and 1. Okay, so let's think about it. How many bits do I have to borrow to come up with 8 networks? 2 to the power. When you borrow bits, you borrow from the left to the right. Okay, if I borrow 1 bit, 2 to the 1 equals 2. That's less than 8. So I'm looking for a number n, right? That is going to be what? Equal or greater than what? 8 networks or subnets. That's what I'm looking for. So if I borrow 1 bit, 2 to the power 1 equals 2. That's less than 8. 2 to the power 2 equals 4. That's less than 8. 2 to the power 3 equals 8. So I have to borrow 3 bits to get 8 networks. See this? 3 bits. So which bits did I borrow? These are the bits that I borrowed. So what I'm going to do is I'm going to copy and paste this. I don't want to waste a lot of ink. So watch this. So I'm going to paste this right over here. Dot the bits that I borrow. That's what, folks, they turn into ones. 1, 2, 3, and the rest is for the host portion. I never messed with those. So which bits did I borrow? What is the value? This is the value. So what I do is I calculate. This is still a 255. This is a 255. This is a 255. Now, what is this one over here? 128 plus 64 plus 32. So it's 128. Let me write this down here. Plus 64 plus 32, which means these are the bits that I borrowed. They turn into ones. What do I get? 255, 255, 255 dot 128 plus 64 is 192 plus 32 is 224. This is my new subnet mask. New subnet mask after subnetting. So it's a dot 224. It's no longer a dot zero. Okay, so it's no longer a dot zero. You want to keep that in mind. How many bits are left for the host? 5 bits. All right. So I come down over here and I say 2 to the power of 5. Then I always have to say minus 2. Yes. Why minus 2? Because I cannot use a network ID and I cannot use a broadcast. 2 to the 5 is 32 minus 2, which equals to 30 hosts per a network. So every network gets 30 hosts. So I get 8 different networks, and every network will get 30 hosts. Okay. Well, let me see how I do the calculation. For example, what is the value of the last bit that you borrowed? It's a 32. What does that mean? Okay, so 32 is your jump start. 32 is your increment number, but I always have to start with a zero. Always, no matter what, you start with a zero network. 0 plus 32 is 32. Plus 32 is 64. Plus 32 is 96. Plus 32 is 128. Plus 32, you see this? I am doing 32 each one of them is 160, then 192, then 224, then 256. If you know that you did something right, you always have to start with a zero, and you always have to end with a 256. These are like wild card numbers, and you're always going to see 128. That means you're doing the calculation right. These are the networks. Every network gets 30 hosts. Okay, so what I do is this. The first 3 octets don't get modified. So 100.0 is my first network. What is my next network? 192.168, 100.32. What is my third network? 100.64. You see that? What is my fourth network? 100. Yes. dot 96. Then 100.128. Then 100.160. Then 100.192. See, the first 3 octets don't get modified. Then 100 dot what 224. Then my last network is 100.256. Do I write this down? Look what I'm trying to show you here. I am putting my last octet right now. See this? Up to here based on the numbers that I get here. So just to let you know, you put the first one. Yes. So network number one, network number two, network number three, network number four, number five, number six, number seven, number eight. So we don't write this down. So don't confuse yourself. So this one, I don't write it down. But I always have to end with a what? With a 256. So now I have eight different networks. Let me put a lot of spacing. So these are the network IDs, as you see. Okay, so I have my network IDs. This is my first network. Okay, this is the first network. This is my second network. And this one over here is my third network. Right? And this one is my fourth. And each one is on a different network, which means they cannot talk to each other. Fourth network. And this is my fifth network, right? So this is the fifth network. This one is the sixth network, right? So this is the sixth network. And this one is the seventh network, all right? So this looks good so far. Seventh network. And this one is my last network, which is the eighth network. See that? Just like this. These are network IDs. I cannot put them as an IP address as long as I'm using which subnet mask? This one right over here. So you know what I could say? I could say the following right now. It's a 192.168.100.0 slash what? I had slash 24 before. Now it's a slash what? Slash 20. See that? So when you see a slash 27, that means, there's 3 bits stolen from the last octet. So that's how many bits are turned on for the subnet mask. Okay, so it's a slash 27. This is a classless network. Let's continue. All right. So this is my first network. So if I'm talking about this, 192.168.100.0 is what? My network ID. Okay. What is the first host? 192.168.100.1 is the first host. So this is the first host. What is the last host? Well, my next network is 32. What is the number before that? Which is 31. That's the broadcast. And before that is the last host. So my last host is 100.30. See this? This is the last host. And my broadcast is 31, which means I cannot use this IP address. So this is the broadcast ID. All right. So first host, last host, network, broadcast. So every network gets 30 hosts from the number 1 to the number 30 is 30 hosts. And all of them are going to be a slash 27, or this is my actual subnet mask. Because if I don't put this subnet mask and I leave it as a 0, my system will think that I'm not actually subnetting. All right. Now, my next network, 192.168.100.32 is my what? Yes, network ID. What is my first host? 33. All right, this is my first host. And what is my last host? My next network is 64. So the last host is 62, and 63 is what? The broadcast. Correct. So this is the last host, and my broadcast is 63. So this is the broadcast. In other words, this number and this number, I cannot put them as IPs. If you count from 33 to 62, you will get 30 hosts, just like from 1 to 30. My next network, watch this, 192, right? 168. 100.64 is my network ID. What is my first host? 65. All right. 100.65 is my first host. What is the last host? Well, the next network is 96. So the broadcast is 95. The last host is 94. 192.168.100.94 is the last host. And the broadcast is what? 95. All right. This is the broadcast. Now, for the 96 network, what is the first host? 97. So let me put the network ID first. So 96 is the network ID. What is the first host? 97, right? This is my first host. And the last host is 126, is the last host. And the broadcast is 127. Look at this. This is the broadcast. See that? Just like this. Your homework is to do the fifth network, the sixth network, and the seventh network. Let me do the last network. So the network ID is 100.220 what? 4 is my network ID. And what is the first host? 100.225 is my first host. And what is the last host? 254. 100.254 is the last host. And the broadcast is what? 255. This is the broadcast. Just like that. See this? That's what I have. So I do have a few networks that I could actually mess around with, right? As you see. So remember, based on the value of the last bit that I borrow, that's my increment number. I keep on jumping by that number until I reach what? 256. All of these hosts, what subnet mask do they use? They use the 255, 255, 255.224, which is a slash 27, right? That's what they do. So let me focus a little bit over here. So if I go back to my Cisco packet tracer, I get myself a switch just to prove a point here, right? And I get a few computers. Let's say 1, 2, 3, 4. And let me get actual cables. There we go. See that? I have 4 connections. And I go ahead and I open this laptop and I go to desktop. And let me say I want to put something from the 32 network. I cannot put 32. Let me prove that. Watch this. So if I go over here and I say 192.168.100.32, you're going to tell me, like, we cannot do that. Well, we have to change the subnet mask. 224. Ah, there you go. Oh, you can't put that. That's a network ID because I'm putting 224. Okay, well, let me go ahead and put the broadcast, which is 63. So I'm going to go back and put 63 as an IP address. 100.63, and I have to change the mask to 224. See that? I can't. This is a broadcast. So I cannot put the network ID or the broadcast as long as I'm changing my subnet mask because I'm subnetting. This is classless network. So what I'm going to do, the first one is going to be 33, and the next one will be, let's say, 43, within that range. All right. So 33, 192.168, 100.33. Then I'm going to change this to 224, and this one will be 43. 192.168, 100.43. And I'm going to change this to 224. Then I'm going to go back. That belongs to the 32 network. Let's choose the 96 network. So I'm going to put 97 and then 107 for another one. But I could use any number within this range. Remember, I cannot put this as an IP, and I cannot put this as an IP as long as the mask is .224. So 97 and 107. So this is going to be 97, 192.168, 100.97, and I'm going to change this to 224. And then this one is going to be 107 within that range. All right. 192.168, 100.107. And I'm going to change this one to .224. Look, if I maneuver the mouse, oh, it's a slash 27. Okay. Look at this slash 27, which is .2. which is 255, 255, 255. That's 24 bits. Then dot 224. How do I get the 224? 128 plus 64 plus 32. And look at this one over here. All them and all them. Okay, so what does that mean? If I put envelope here and here, communication works. They're on the same network. Here and here, communication works. If I put envelope, let me just delete these ICMP packets here and here. They're not going to be able to talk to each other. Let me try it again. So you could also open the command prompt and test it. See, it's failing. What's the IP address of this? This is 107. So if I open here and I go to command prompt and I say ping 192.168.100.127, it's not going to work. Why? They're on different networks. So no longer you're going to listen to the first three octets. As long as the subnet mask is .0, then yes, because we are following the subnet mask rules. But when we're subnetting, you don't care about the first three octets anymore. You have to follow the slashes. And that's how you know which network you're on. See, there's no way they could actually talk to each other. These two can talk to each other, and these two can talk to each other. Why? Because this one belongs to which network? To the 32 network. This one belongs also to which network? To the 32 network. This one belongs to which network? To the 97, and then there's what? 107, right? So this belongs, check this out, which is to the 96 network. First host, last host. You see that? So they cannot talk to each other because they're on different networks. So I do get 8 networks, right? I do get 8 networks, and every network gets how many hosts? 30 hosts per a network. All right, so let's take a look at and see another example. Let's say I have 192.168.100.0/24. And on a previous example, we were looking for 8 networks. Let's say, for example, I'm looking for 4 networks, right? Just like this. So I'm going to say 192.168.100.0. This is my network ID. My default mask is 3255.0. That means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to ask myself, right? So I'm looking for 4 different networks, 4 different departments. 2 to the power of n is equal or greater than what? 4 networks, just like this, right? So how many bits do I have to borrow from the last octet to get 4 networks? If I borrow 1 bit, 2 to the 1 equals 2. 2 to the 2 equals 4. So I have to borrow 2 bits, all right? So 2 to the power of what? 2, which equals to 4 networks, just like that. So which bits did I borrow? Let me just copy and paste this right over here. Dot 1, 1, and the rest is all what, folks? Zeros, just like that. Okay, so what is the value of the bits that I actually borrowed? So what I'm going to do is I'm going to do that right over here again. 128, you have to remember this. 8, 4, 2, and 1. So I borrowed 11000000. 2 bits. 128 plus 64 is 192. So 255, 255, 255 dot 128 plus 64, which equals to 192. So 255, 255, 255 dot 192. This is the new subnet mask after subnetting, which means what? Now it's 192.168, 100.0 slash what? By default is a slash 24 bits. See this? Then I want to get 2 more bits, which is a slash 26. Now it's a slash 26. You see that? I do have a slash 26. Okay, how many bits did I borrow? 2. How many bits left for the host? 6. Okay, so I'm going to say 2 to the power of the bits are left, then always minus 2 because you can't use the network ID of the broadcast. 64 minus 2, which equals to 62 hosts per a network. So I get 4 networks, but every network gets 62 hosts. All right. So in other words, this is my new subnet mask right now after subnetting, and it's actually a slash what 26 because I'm looking for 4 different networks. Okay. So what is the value of the last bit that I borrowed, which is this one? That's a 64, right? So I'm going to say 0 plus 64. I always have to start with 0 plus 64 plus 64 plus 64. Here are my 4 networks. Okay, so what is my first network? 192.168. The first three octets don't get touched. 100.0. My second network is 100. Yes, 64. My third network is 100.128. That's the third. And my last network is 100.192. Remember, we don't put the 256. So I cannot put this as an IP address. I cannot put this as an IP address. Same thing over here and same thing over here. As long as my subnet mask is what? 192. Because then the system will understand what I'm actually doing here. So if this is my network ID, what is the first host? 100.1. What is the last host? Well, what is the next network? It's 64. So, and the one before that is a broadcast. So last host is 62. And the broadcast is what? 63. So this is my network ID, right? This is the first host. This one is the what? Last host. And this is the broadcast. 64 is the network ID. What is the first host? 100.65. The last host is 100.126. And the broadcast is 100.127. Look at this. The one after the broadcast is the next network. So this one is 100.129 is the first host. And look, what is the next network? 192. All right. So the last host is 190. And the broadcast is what? 191. Just like that. My last network, this is the network ID. First host is what? 100.193. Last host is what? 254. All right. And the broadcast is what? 255. Just like this. You see that? That's how I do so. So what I'm going to do right now is let me simulate this in Cisco Packet Tracer. So I'm going to go back over here. And if I try to put, let's say, the number 64 as an IP address, 192.168.100.64, but then I have to change this to 192. They can't. Okay, what is the broadcast 127? Let me try and put that as an IP address, and this will actually fail also. Remember, we can't use a network ID and we cannot use a broadcast. 100.127, and I have to switch this one to 224. Look at this. I can't actually do that, right? So that's not something I could actually do. All right, perfect. So I'm going to close and close because the network ID in the broadcast I cannot put as an IP address. Well, what I want to do is one of them will be, let's say, 65, and the other one will be 75. That belongs to the 64 network. So every network, look how many hosts they get. 62 hosts per network. If you count, you get 62 for each one of them from 129 to 190, from 193 to 254. But I get how many networks? As you see, four different subnets, four different departments. One for phones, one for laptops and desktops and servers, and one for actual printers, and the other one for cameras, and so on. Or it could be per a department. So one of them is going to be what? Let's go back and put the numbers in. So I'm going to go back over here and put this 192.168, 100 dot what? Let's say 65. And this one is going to be 192. All right. Now let's say this one is going to be 75. 192.168, 100.75. And I have to switch this to 192. And then that's a 64 network. Then I'll use the 128 network, different network. Let's say 129 and 139. 129. And this one is going to be what? 192, 129, and 139. If I want different networks to talk to each other, then I need to get myself a what? A router, right? And this one is 139. And this one is dot 224, dot 192. So remember, if you want different networks to talk to each other, you have to get yourself a router, or you can do static routing. So I'm going to close this out and close this out, right? So watch this now. This is one network, 65 and 75 are on the same network. They belong to the 64. This belongs to the 128 network. And this belongs also to what? The 128 network, because it falls into that range. From one what? See that? From 129 to what? To 190 belongs to this network. So I have two different networks over here. So if I put envelope here and here, they could talk. Envelope here and here, they could talk. If I put envelope here and here, there's going to be a failure. And then if I put the envelope again here and here just to try it, it's going to be a failure. So I could actually do this. So remember, it's a slash 26. So this is 129. So if I open this command prompt and I ping, I like to ping it with a negative T. So it's constant ping. It's good for troubleshooting 100.129. It's going to fail. Why? Because it belongs to a different network. All right. It belongs to a different network. So let's take a look and see here. It's going to time out. Only these two can talk to each other, and these two can talk to each other. If I want them to talk, then I have to configure routing in between. So this is my second example of subnetting a class C. Well, take a break right now. Go back to this, redo it again. It's good to get a piece of paper and a pen instead of just watching it, right? When you write it down, you will understand it better. So what we're going to do is we're going to continue still subnetting a class C in our next lecture. Bye now. Okay. Hello, everybody. Welcome back. It's Mo again. Let's go ahead and continue with subnetting a Class C network. So far, we found out we're looking for four networks. We had to borrow what? 2 bits. We were looking for more networks, such as 8 networks, and I had to borrow 3 bits, right? So let's take a look and see. If you're noticing something, I am actually subnetting a private network. This is actually internal. Like ISPs will be subnetting a public IP, which is right, a global IP address. Now watch this. Let's say we got 192.168.100.0/24. And I'm looking for 14 networks. That's how many networks I'm actually looking for. So I'm going to put the number down here and I'm going to put the default mask dot zero. And of course, I want to get these binaries in the list. All right. Without them, there's no way that we could actually do anything. So if I want to actually get 14 networks, how many bits do I have to borrow from the last octet, which is the host portion, right? Remember, we cannot mess around with the first 3 octets. So I'm going to say the following. This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm going to say 2 to the power of what is equal or greater than what? 14 networks, right? So I'm going to say 3 to the power 2 is actually 4. 2 to the power 3 is 8. 2 to the power 4 is 16. So I have to borrow 4 bits to get 14 networks, but I'm getting 16. Okay. So, but I'm looking for 14 networks. So 2 to the 4 is 16 networks. Why am I doing it this way? Let me explain why. I could have said, you know what, folks, let me get 16 networks and let's make it super easy. 2 to the 4, which equals 16. So if I was looking for 16 networks, 15 networks, 14 networks, 13 networks, 12 networks, 11 networks, 10 networks, 9 networks, I still have to borrow 4 bits. Because if I borrow 3 bits, do you notice this? Borrowing 3 bits only gives me 8 networks. So if I wanted to get 9 through 16, I have to borrow an extra bit. For example, right over here. I'm looking for 4 networks. So I had to borrow how many bits? 2 bits. If I was looking for 3 networks, I still have to borrow 2 bits. So it doesn't have to be exact the same, right? Okay, so just want to make sure that's actually clear. So we borrowed 4 bits. Let me copy this so we don't waste a lot of ink. Ink is kind of expensive, all right? So dot 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a 255. That second octet is a 255. The third octet is a 255. Dot what? What are the value of the 4 bits that I borrowed, right? Which is what? 128 plus 64 plus 32 plus 16. So I'm going to put this in the list. And I'm going to put 255, 255, 255. Dot what? 28 plus 64 is 192 plus 32 is 224 plus 16 is 240. So now my new subnet mask is 3.240. I could say this. It's a 192, a 168, a 100.0 slash what? 28, because I have 28 bits for the subnet mask, right? Okay. How many bits did I borrow? 4. How many bits left for the host? 4. So I'm going to say 2 to the power of 4 minus 2, which equals 16 minus 2, which equals to 14 hosts per a network. So I do get 14 networks. I could get 16, but I'm looking for 14. But every network gets what? 2 to the 4 is 16 minus 2, 14 hosts per a network, as you see, right? Okay, now let's put it this way. What is the value of the last bit that I borrowed? Well, it's 16. So my jump start is what, folks? Is 16. So I'm going to say 0, 16 plus 16 plus 16 plus 16 plus 16 plus 16. So I keep on adding 16. You see that? My jumps are 16, 176, 192. You see this? 208. And after that is what? 224. And then after that is 240, then 256. You see, this is a wild card number. I'm always going to get 128, and I'm always going to end with 256. So I know I'm doing the work perfect. Okay, the first three octets don't actually change. We never can mess with them because that's from the network portion. So 100.0 is my first network. Then 100.16 is my second network. You see this? Then 100.32 is my third network. Then 100.48 is the fourth network. And then 100.64, see that what I'm doing? Only the last octet is the one that I'm actually modifying. Then 80 eventually is going to reach what? 100.224. And the last network is 100. What? 240. So if you count how many networks, network number one, network number two, network number three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I do get 16 networks, but I'm looking for how many networks? 14. And that was the closest number is by borrowing 4 bits. The subnet mask for all my networks is .240, which means it's a slash 28, right? So let me go ahead and look at one of the networks. Let's say the 16 network. The network ID is what? 100.16. This is my network ID. See this? This is a network ID. My first host is 100.17. Can you see this? This is the first host. Now, the last host is what? Well, my next network is 32. The last host is minus 2, which means this is 100.30. All right. This is the last host. And then the broadcast is 1 minus the next network, which is 100.31. And this one over here is the actual broadcast, as you see, right? So that's only for the 16 network. Let's say the 48 network, right? Let's fill in these. So my network ID, which means I cannot put this as an IP address, as long as I'm putting what? 240 as a subnet mask. My first host is 100.49. My last host is what? Well, the next network is 64. Yes, 62 is the last host. And then 63 is a broadcast. So this is my network ID, which is the subnet ID. I cannot put as an IP address. This over here is the broadcast, all right? This is the broadcast ID. And this one is the first host. See this? This is the first host. And then I get the last host, right? Last host. That's what I get. So I get from 49 through 62, how many hosts? From 17 to 30, how many hosts? 14 hosts per a network. Well, let's actually test that. So I do get 16 networks. I'm looking for 14, and every network gets 14 hosts. Let me go back to my Cisco packet tracer and plug these in. So remember, this is a slash 28. All right. So let me get myself a switch. Here's a switch. Let me get myself 4 computers, just like before. 1, 2, 3, 4. And let me put the actual cables from here to here. There you go. Right. So I have 4 computers here. So let me go back to my chart. One of them is going to be, let's say, for example, 20, and the other one can be 30 from the 16 network, 20 and 30. First of all, can I put 16 as an IP address? 192.168.100.16. And I have to switch this to 240. Oh, you can't. All right. because that's the network ID. Well, can I put the broadcast as an IP address 100.31 and then I get 240 over here? And I can't. Okay, so I could put 20 on one of them. That belongs to the 16 network, right? And I have to change this to 240 and then 30, let's say. And this one is 192.168, 100.30. And I'm going to make this as what? 240, as you see. See that? Just like this. So if I maneuver the mouse, here's the mouse, 20/28. And this one is 30/28. So the 20 and the 30, they belong to which network? To the 16 network. Now let me go ahead and put something here. So I'm going to make one as 50, one as 60. 50 and 60, they belong to the 48 network. 50 and 60. And watch this. So this one is 192.168, 100.50. And this one is 240 and close and close. And this one is going to be 60, 100.60. And this is 240. And close and close. Let me maneuver the mouse. Watch this. Okay, so this is 100.50/28, and this one is 100.60/28. Now, 50 and 60, they belong to the 48 network. So this is perfect. What does that mean to us? If you belong to the 16 network, you only can talk to the 16 network without a router. If you belong to the 48, you only can talk to the 48 without a router. So these two cannot talk to each other. Let's test it. Let me put an envelope over here, an envelope here. Success. Okay, good. Envelope here, an envelope here. Success. Very good. If I put envelope here, an envelope here, it's going to fail. It's a different network. Remember, this is a classless network. It's going to fail. Why? Because they belong to different networks, right? So I like to do it more than once because sometimes the first one always fails. So it actually failed as you see. So what I just did right now in this example, I was looking for 14 networks and I had to borrow 4 bits. Even when I borrowed 4 bits, it's 16 networks, but that's actually the closest number, right? Most likely you'll be dealing with something like this for what? For internal organization. What if I have something like this? Public IP. This is what the ISP will actually do. /24. And I'm looking for 64 networks. And you'll see why I chose 64. So this is what the ISP will actually do. So 210, 210, 210.0, the default mask, 0. So let me put 128, 64, 32, 16, 8, 4, 2, 1. And I'm looking for 64 networks. Let me convert 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. All right. So how many bits do I borrow from the last octet to get 64 networks? So look, the first 3 octets is a network ID, right? So I'm going to say the following. 2 to the power, okay, of 5 is 32. 2 to the power 6 is 64. So 2 to the power 6 equals 64 networks. See that? How many bits did I borrow? 6 bits. Let me copy this right over here. And then 1, 2, 3, 4, 5, 6, 7, 8. So I put 6 ones and I have 2 zeros because I actually borrowed 6 bits. How many bits left for the host? 2 bits. Okay. So what does that mean? 2 power of 2 minus 2. Why minus 2? I cannot use the network ID. Remember, folks, we cannot use the broadcast. 2 to the 2 is 4, minus 2 equals 2 hosts per network. Why would I ever think about it? Why would I ever have 2 hosts per network? In what case? I mean, really think about it. I mean, normally this is something that you do a point to point connection. I would say ISPs actually do that. ISPs try and do that. Why? They get more customers, right? More customers, and they just need less hosts. Every side is on a different network. For example, between me and my service provider, I am actually on the same network with the ISP. Between you and your ISP, you're on the same network. How do you think you connect to the internet? Well, you have to go through your ISP, and from the ISP, you're getting actually online, right? So keep that in mind. I'm looking for more customers, but less hosts per a network. That's what we're actually looking into over here. So what I want to do is the following. I have 6 bits. Let me put this thing over here. Remember, this is something you better remember all the time. All right. You always need that. So 1, 2, 3, 4, 5, 6, 7, 8. I'm not using the last two. Okay, good. So what does that mean to me? 255, 255, 255 dot what? 128 plus 64 is 192, 224, 240, 248, 252. So this is dot 252. Now, each network gets 2 hosts per a network. So every network gets only what? 2 clients. Why? One goes on the ISP side, an IP goes on the ISP side, and then there's an IP that goes on the customer side. That's why you have a dedicated connection with your ISP. It's a point to point connection. All right. So ISPs always use a slash what? Slash 30. So I could say this is a 210, 210, 210.0/30. Why? Because look, I'm using 24 bits plus 6 is a slash 30. That's why I'm doing this. So whenever you see a slash 30, it's like a point to point connection. And only ISPs actually use that. So let me show you. What is the value of the last bit that I borrowed? It's a 4. Okay. 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. See, I'm jumping by 4 every time. These are for different customers. Every customer is on a different network. 48, then eventually he's going to reach what? Let's say 4 times 50 is 200. It's going to eventually reach 200, then 204, then 208, then 212, then 216, 220, 224, 228. You see this? 232, 236, 240, 244, 248, 252, 256. So I did the work correct because I'm actually ending with 256. All these are networks. Remember, I skipped from 48 and I jumped all the way to 200. Just multiplied 4 times 50. Eventually, it's going to reach 200. Okay, let's take a look at one of our networks. 210, 210, 210 dot, let's say 20, right? Which is this one over here. Network number 1, network number 2, network 3, 4, 5, 6. So this is dot 20. All right. So this is good. Now, what is the first host? 210, 210, 210 dot 21. The next network is 24. So what is the last host? 210, 210, 210 dot 22. And what is the broadcast? 210, 210, 210 dot 23. So this is my actual network ID. Watch this. This is what ISPs will use. This is the network ID, right? Which is the subnet. And then you got this as the first host, and you got this as the last host. So what does that tell you? Every network only gets how many hosts? 2 hosts. And then this is the broadcast. There we go. So I have my network ID, I have the first host, I have the last host, and I have the what? The broadcast. That's what I have over here. See, this belongs to the 20 network. Let's take a look at another network. 210, 210, 210 dot, let's say 212. All right. This is the network ID, right? So this is the network ID. My first host is 210, 210, 210.213. So this is my first host. And my last host is 210, 210, 210. At what? The next network is 216. So the last host is 214, right? And look at this. This is the last host, as you see, right? So that's the last host. Now, what is the actual broadcast? Oh, it's 215. One minus the next network, right? So look, 210, 210, 210, 215 is my actual broadcast. So look at this. This is the broadcast. Now, all of them is a slash 30.252. Well, let's test. Remember, I did this with a public IP because ISPs will actually use that, right? So watch this. So it's a point to point connection. Whenever you have a connection from like a router to a router, you'll have a slash 30. Why? Because you're not trying to waste host IP addresses and you get more networks. That's why they use a /30. So if I go ahead to this machine, remember if there's no DHCP server, we get a people 169.254 dot something dot something. That's a private for class B. All right. So I'm going to give the first one 21. But let's say I want to put 20, 210, 210, 210.20, and I make this as 252. It says you can't. This is a network ID. Okay, good. So which means we're doing perfect. 210.23, and I make this as what over here? As at the end, 252. I can't. That's a broadcast, which means I have to put 210 dot what? 21. And this one is a 252. Then I'm going to close this. That's a 21. This is a 22. 210, 210, 210.22. And I'm going to make this as a 252. See that? Just like that. Then I'm going to close. Then I'm going to close. Right? So this is actually good. Then I'm going to make the other one as 213 and 214. So this is going to be 213 and the other one is going to be 214. 210, 210, 210, 213, and a 252. And this one is going to be a 214. 210, 210, 210.214. And this one is going to be a 252. Then close, then close. And look at this /30. See that? So remember, this is only for public IPs, only point-to-point connection. And there we go. Unless you have a point-to-point in your server closet, you could use a /30, but most likely ISPs tend to use this. Let me delete it. So if I put envelope over here, an envelope here, they could work. Envelope here, an envelope here, they could work. Well, envelope here, an envelope here is going to be a failure. See that? I'm going to try it again. Envelope here and envelope here is a failure because they belong to different networks. ISPs always have a /30. It's a point-to-point connection. As I said, internally in your organization, if you have a point-to-point connection from a router to a router, you should have it as a /30, right? Internally. But normally you don't actually see that. Every location should only have one router because the router is the one that connects you to where? Yes, to the internet. You don't need more than one. Even though you have a backup, there's going to be a virtual IP address. So most likely service providers will use something like this. All right. That's what I wanted to show you in this lecture. So we did subnetting with class C. And let's take a look and see what we're going to be looking at in our next lecture. Bye now. Okay. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, what we're going to do is like a reverse engineering of a subnetting for Class C. What do I mean by that? Let's say you already have something like this 192.168.100.0, and let's say it's a /29. We didn't do a /29. We did /20. 6/27. We did /28. We did a /30. All right. We didn't do a /29. What do I mean by reverse engineering? Well, if I see something and it's already a /29, what do I understand from it? What do I reverse engineer this? For example, I know that it's 192.168.100.0, and this is 255, 255, 255.0. Well, if it's a /29, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And this one should be 1, 2, 3, 4. That's what? 24 plus 4 is 20, 25. There you go. That's 29 bits, right? So I'm using 29 bits. Look, /29, I got 8 bits. 8 bits. 8 is 24 plus 5 is 29 bits. What does that mean? It's a 128, it's a 64, 32, 16, 8, 4, 2, 1. So I put over here 1, 1, 1, 1, 1, and 0, 0, 0. So 5 bits are actually borrowed from the last octet. So what does that mean? So this one is a 255, 255, 255 dot what? Okay, 128 plus 64 plus 32 plus 16 plus 8 plus what? That's it. All right, there we go. 5 bits. What do I get? 255, 255, 255 dot 248. You see that? I'm reverse engineering the subnet that I'm actually looking at. All right. So how many bits left for the host? 3 bits left for the host. Okay, that's cool. To the power of 3 minus 2, which equals 8, minus 2, which equals to 6. hosts per a network. See that? 6 hosts per a network. That's what I'm getting over here. So every network gets 6 hosts. But where are the networks? Well, I know this is a class C. So the first 3 octets are not touched. Oh, there you go. So 5 bits were borrowed. Okay, 5 bits were borrowed. I would say 2 to the power of 5, right? So 2 to the power of 5. Oh, there we go. 2 to the power of 5 then equals to what? 32 networks. So I do get 32 networks. I just reverse engineered this. The value of the last bit that I borrowed is an 8. Okay, good. Watch this. 0, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Then what? 104. I'm just jumping by 8 on each one of them, as you see. Then it's going to be 112, then 120, then 128, then 136, then 144, then 152, then 160, then 168, then 176, then 184, then 192. You see that? I'm jumping by 8 on each one of them. Then 200, then 208, 216, then an 8 is what? 224. I'm doing good because I see a 224. I see the 128. That's a perfect sign. And 8 is what? 232. And then 8 is 240. 248. There we go, 256. I just reverse engineered this. See that? Which means this is my first network. This is my second network, my third network, fourth network. Every network gets 6 hosts. So my first network is 192.168, 100 dot what? 8. First host is 9, last host is 14, 15 is a broadcast. The 40 network, 40 is the network ID. I cannot put it as an IP address. 41 is the first host, 46 is the last host, and 47 is a broadcast, as long as I'm using this as a subnet mask. You see that? That's how you reverse engineer. Let me give you another example for reverse engineering. 192.168, 100.0, and let's say a slash what? 26. Did we do a slash 26? Let's take a look. Let's go all the way up. We did a lot of examples over here. All right. So I was looking for 8 networks, which means slash 27, right? I have a slash 27. I got a slash what? 26. We did 6. So we did 26. We did 27, right? And let's see what else we did. We did 28, right? We did 29, right? This is a 29, and we did 30. Which one we didn't do? A slash 25. Okay, we didn't do that. Slash 25. What does that mean? Let's take a look. All right. Okay. 192.168, 100.0, then 255, 255, 255.0. Okay. How do I get 25 bits? Well, let me put this here 64, 32, 16, 8, 4, 2, 1. Okay, 1, 2, 3, 4, 5, 7, 8. 8 ones is a 255. So this 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then what? I'm getting 25 bits. How do I get 25 bits? 1 and all what? Zeros. So this is a 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what does that mean? 255, 255, 255 dot what? Oh, it's 128. So I'm going to make this as what, folks? 128. How many bits did I borrow from the last octet? 1. Okay, what does that mean? 2 to the power of 1, which equals 2 networks, right? How many bits left? Oh, 7. And look at this. I got 7 bits left. So now I could say 2 to the power of 7 minus 2, which equals 128 minus 2, which equals to 126 networks. You see this? Free network gets 126 hosts. Okay, what is the first network? I mean, I only have 2 networks. Well, the value of the last bit that I borrowed is a 128. So guess what? This is super easy. 0, 128, then 256. So my first network is 192.168, 100.0. My second network is 192.168, 100.128. So I cannot put this as an IP address. I cannot put this as an IP address as long as I have this as a mask. So what is the first host here? Yes. That's a one. What is the last host? Well, the next network is what? 128. So the last host is 126. And then the broadcast is 127. See that? So I get, as you see, 126 what? Hosts per a network. Per a network. That's how much I actually get over here. So I get two networks, then I get 126 hosts per a network. So from 1 to 126, that's 126 hosts. Then this is a network ID. I cannot put it as an IP address. 192.168, 100.129 is the first host. My last host is 100 dot what? Yes, 254, and the broadcast is 100.255. See that? I mean, this is really the possibility of subnetting for a class C. I mean, we're talking about folks, what? Private or a public range, right? As you see, it's super simple. You just have to practice. You want to do this? Get a piece of paper, write it down. That's how you learn this. Don't just stare at the screen, all right? You want to write it down. It's going to help you a lot, all right? So that's it for subnetting a Class C. In our next lecture, we're going to be subnetting Class B. Then after that, we're going to be subnetting Class A. So whatever you face in the field, you'll be able to look at two numbers and say, can these two numbers talk to each other? Do they belong to the same network? Do I need to route between them? And then I'll show you how we could simulate it in a real environment. But first, we want to just do the subnetting for all the classes. So we'll see you folks, all right, in our next lecture, subnetting Class B. Bye now. Everybody, welcome back. It's Mo again. Well, in this lecture, we're going to be looking at the subnetting a Class B. You're going to wonder, most commonly at work in an actual corporation, you'll be using internally a Class C. I mean, there is Class A subnetting, there is Class B subnetting. Most likely that could be for a data center, for an ISP, for an MSP, for a CSP, a cloud service provider. But let's take a look and see how this actually works. So, what is a private for a Class B? 172.16.0.0, right? This is a class B. Remember, class B, the first octet falls in between 128 and 191. So by default, this is a slash 16, all right? So watch this. Once I do 16.0.0, the default mask is 255.255.0.0. Let me put the actual binaries. All right. Remember, we always need this. Without this, you cannot do anything. All right. If you really think about it. So of course, 111111111, and then 000000000. So this is all ones. This is all ones, zeros. That's why I have a slash 16. So let's say my question is that I'm actually looking, let's say, for example, for 30 networks. Okay, let's see how this works out versus a class C subnetting, right? So watch this. 2 to the power of what is equal or greater than 30 subnets or 30 networks, right? That's what we need to look into. Okay, so when I borrow bits, this time I have my third octet and my fourth octet. Okay, so let's take a look. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. There you go. All right. Now, I cannot touch or mess around with the first two octets. I can start stealing bits from the third octet. I don't jump to the fourth octet. If I borrow one bit, 2 to the 1 is 2. That's less than 32 bits. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. So I have to borrow 5 bits. 2 to the 5, which equals 32 networks. All right. Okay, good. Now, let me go ahead and copy these. All right. These did not actually change because I cannot mess with the first two octets. 1, 2, 3, 4, 5, 6, 7, 8. And this is also, I didn't mess with it. See how they stay? All right. Okay, good. Which bits did I actually borrow over here? I borrowed these bits 128, 64, 32, 16, and 8. So this is a 255, 255. And then this one is what? 128 plus 64 plus 32 plus 16 plus what? 8. Right? And dot what? 0. Remember, the fourth octet is not touched. So 255, 255 dot. I add these up together, I get 248. dot 0. So what do I do here? 172.16.00 slash what? How many bits am I using for my network portion? Right? 21. So now it's a slash 21. Okay, cool. How many bits? I did not mess around with. 3 plus 8 is 11. Okay, 2. See how I calculate? To the power of 11, then minus 2 equals what? Let's get online. Let's get online and look for Google. All right. So look at this. So 2 to the power 11, 2 to the power 11 minus 2 equals what? 2046 hosts per a network. So 2046 hosts per a network. See how many hosts I have? So would you ever use this at work? Of course not. But we're trying to see how subnetting is over here. Okay, so how do I calculate my networks right now? The subnet mask for all of them is this one right over here. Okay, great. Well, what is the value of the last bit that I borrowed on the third octet? It's an 8. Okay, good. If it's an 8, I always have to start with a 0. All right. 0, 8, 16, 24, 32. 40, 48, 56, 64, 72, 80, 88, 96. Eventually, 8 times what? Like 8 times 40, 8 times 30 is 240. So eventually it's going to reach 240, then 248, then 256. See that? These are the actual networks. So I get 30 networks. Each network gets 2,000 what? 46 hosts. How do I calculate that? 172. 16. Now I'm messing around with a third octet. So these numbers over here, they go to where? The third octet. That's where they go to. All right. So 0.0 is my first network. 172. 16. 8.0 is my second network. Then 172. 16. Dot what? 16.0 is my next network. Then 172, 16 dot what? Yes. 24.0 is my next network. Then 172, 16 dot what? Eventually it's going to be what? 240.0 is going to reach that number. And my last network is what? 248. 16, 248.0. These are network IDs. So I cannot put this as an IP address. Let's check that out. 8.0. Let me get myself a switch. See that? And let me get myself a few computers. 1, 2, 3, 4. And here's the actual cables. And right over here. Okay, so I'm going to go to the first one and say 172.16.8.0. And the mask will be what? 248.0. Look what's going to happen now. It's like negative. This is the network ID. You cannot put it as an IP address, right? So let me go back over here. So this is the network ID. What is the first host? 16.0.1. All right. What is the last host? Well, what is the next network? It's 8.0. So what's the number before 8.0? 7.254 is the last host. And the broadcast is what? 7.255. What comes after 7.255? 8.0. All right. So this one, what is the first host? 8.1. What is the last host? The next network is 16.0. So this one is 15.254, and the broadcast is what? 15.255. How about this one over here? And if you calculate from 0.1 until 7.254, you will be getting 2046 hosts. So this one, 172, 16. 16.1 is the first host. The last host is 23.254, and the broadcast is 23.255. You see that? So if I calculate this one over here, for example, what is the first host? 240.1, and the last host is 247. Yes, dot 254. And then 247.255 is the broadcast. So if I put a number from 0.1 until 7.254, they should talk to each other. So let's say I put 1.255, and then the other one is what? I cannot put 7.255. Look at this. So let me go back and try this. 7.255. 16.7.255. See, it doesn't know unless I switch the subnet mask itself. So I have to let it know it's 248. See that? That's a broadcast. All right, good. So let me go back over here and let's say this one is going to be 172.16, let's say 6.1, all right? And this one over here is what? 248.0. This is good. And this one will be, let's say, 7.1. 172.16, 7.1. And this one will be what over here? 248, right? Just like this. And I'm going to close and I'm going to close. So I already gave numbers from the first range. So 6.1 and 7.1. Then I'll use what? 8.1 and 9.1. 8.1 and 9.1. 172.16, 8.1. And I have to switch this, right? 248. And the other one is 9.1. And this one is 248. So let me maneuver the mouse. Look at the CIDR. It's a /21. All right. Look at this 6171, 81, and what? And this one is 91. All right. So let me put the envelope here and envelope here, success. Envelope here and envelope here, success. If I put the envelope here and here, they cannot ping. See that? I try again. Envelope here and envelope here. They cannot ping. See, it's actually failing. All right. So only these two can talk to each other and these two can talk to each other because they are on what? Different networks. All right. Let's go back and do another example of a class B. 172.16.0.0/16. And let's say this time I'm looking for how many networks? Let's say 120 networks. All right. I'm looking for 120 networks. Okay. Perfect. 16.0.0.255.255.0.0. Right? Just like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of what is equal, right, or greater than 120. Well, let me go ahead and put these in 64, 32, 16, 8, 4, 2, 1. All right. Okay. If I borrow one, remember, I have to borrow from the third octet first. I cannot mess around with the first two. It's a class B. If I borrow 6 bits, 2 to the 6 is 64. 2 to the 7 is 128. So I borrow 7 bits. 2 to the power 7 equals 128 networks. Right. So I borrowed 7 bits. So these stay over here. So let me paste these here. 1, 2, 3, 4, 5, 6, 7, 8. Then these are not touched. See that? So how many bits I didn't mess around with? 1 plus 8 is 9. So 2 to the power of 9 minus 2. Well, 2 to the 7 is 128. 2 to the 8 is 256. 2 to the 9 is 512. So 512 minus 2, which equals 510 what? Hosts per a network. See that? Okay. What is the value of the bits? It's the 255. 255. Dot what? How many bits I borrowed? 7. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus what? 2. Dot 0. Remember, I borrowed 7 bits over here. Okay. So let me put that number in again. 255. 255 dot what? 128 plus 64 is 192. 224, 240, 248, 252, 254. Not 0. See that? So now I could say it's a 172.16, 0.0 slash what? What is the CIDR? I'm using 8 and 8 is 16 and 7, 23 bits. So now it's a slash 23. See that? I have a slash 23. What's the value of the last bit that I borrowed? It's a 2. Okay, perfect. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Eventually it's going to be what? 100, right? Eventually it's going to reach 100, 102, 104, right? Eventually it's going to reach what? 200 network, 202 network, 204, 206, 208, right? Look, I'm jumping by 2, right? 210, 212, 214. 216, 218, 220, 222, 224, 226, 228, 230. And then it's going to reach what? 232, 234, 236, 238, 240. See, that's a good number, 240. That means we're doing good. 242, 244, 246, 248, 250, 252, 254, 256. As long as I end with 256, I should be fine, right? So that's one thing to keep in mind. 256, I should be fine. So what is my first network? Well, that's how they're displayed. 172.16.0.0, 172.16.2.0, 172.16.4.0, 172.16.6.0, 172.16.8.0. Eventually, it's 172.16.200.0, right? See that? 172.16.202. See, I'm messing around with the third octet. Eventually, it's going to reach 172.16.252.0. And the last network is what? 254.0. See that? Let's focus on these over here. All right. So this is a network ID 255. 255.254.0 is the subnet mask. It's a slash 23. So if I go back to my Cisco packet tracer and I say, I want to go ahead and put 172.16.252.0, so it takes it as default, but look at this 254.0. That's a network ID. I cannot put it as an IP address. All right. So what does this mean? This is the network ID. What is the first? Remember, I get how many hosts? 510 hosts. So what is the first host? 172.16.252.1. Last host? What is the next network? 254.0. So 253.254 is the last host. All right. And then 253.255 is the what? Broadcast. What's the number after 253.255? 254.0. And this one will be 172.16.254.1 is the first host. Last host is what? 255.254. And the broadcast is 255.255. Now, let's put a number. Let's say 252 for one of them. 252. 172.16.252.1. And this is 254.0. 252.1. And this one is, let's say, 253.1. All right, 253.1. 253.1. And this one over here is 254.0. So these two are actually on the same network, right? And this one is going to be 254.1, 172.16.254.1. And I have to switch because if I don't switch, it's like, okay, you're not subnetting. All right. Okay, 254.1. And this one is 255.1, let's say. 255.1. And this over here is 254.0. There you go. So if I look at the CIDR, look at this, slash 23, slash 23, slash 23. And you see that? Slash 23. Okay, perfect. These two can talk to each other. These two can talk to each other. These two, like this one and this one, cannot. Let's try again. They're on different networks, or I could open the command prompt and ping. It's the same thing. See that? They failed. That's what I wanted to show you in this lecture, folks. Subnetting for Class B. See, little by little, you will have a good touch of it. Well, we're going to continue subnetting for Class B in our next lecture. So we'll see you folks in a moment. Bye now. Hello, everybody. Welcome back. It's Mo again. We will continue with subnetting on a Class B. All right. So watch this, folks. 172.16.0.0/16. Let's say we are looking for more networks. I know in our previous example, we borrowed like the most is what, 7 bits. What if I borrow a few bits from here? All right. So, for example, what is 2 to the 10, right? 2 to the 10 minus 2, right? What is that? That's 1022. I mean, I don't say minus 2 because I'm looking for networks. So 2 to the power 10 is what? 1024 networks. Let's say I'm looking for 1024 networks. That's what I'm looking for. Watch this, 1024 subnets. That's how much we're actually looking for. So 172.16.0.0 is the actual what? Network itself. The default mask is 255.255.0.0, right? So the formula is what? 2 to the power of what is equal or greater than 1024, right? Equal or greater than 1024 networks or subnets. So how many bits do I have to borrow? So this one is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then how many bits do I borrow over here? Well, first of all, let's put it 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. See that? Okay, so this stays as it is. Let me just copy this. And then how many bits do I use over here? Well, I have to use how many bits? 10. We saw that 2 to the 7 is 128. 2 to the 8 is 256. 2 to the 9 is 512. 2 to the 10 is 1024. So 2 to the power of 10 is equal exactly 1024, right? So how many bits? 10 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And look, these are for the host. So how many bits for the host? 6 bits for the host. See this? 6 bits for the host. 2 to the power of 6 minus 2, which equals what? 64 minus 2, which equals to what? 62, right? Hosts per a network. So 60, 2 to the 6 is 64. Then minus 2, oops, sorry. 2 to the 6 is 64. And minus 2, the numlock, right? Which equals to 62 hosts per a network. That's how much I get. Okay, what is the values? Well, this one is a 255, 255, and this one is also what? This, what did I use? 128, 64, 32, 16, 8, 4, 2, and what? And 1. I used all of them. Dot. What did I use over here? 128 plus what? I used 2 bits over here, 64. So this one is 255, 255, 255 dot what? 192. So what does that tell me? It's a 172, 16.0.0 slash what? How many bits? Oh, 24 slash 2 is what? 26 bits. It's a slash 26. Look, this is a class B with a slash 26. Don't let it fool you because the way I showed in the class C, I did have a slash 26, but I could have a slash 26 for a class B network so I could get more networks. That's the purpose of subnetting is to get more networks, right? That's why you would see who's going to use 1024 networks, not us in corporations, ISPs, CSPs, MSPs, okay? So, but I get how many hosts per an actual network. I see I have 62 hosts per a network. Okay, good. Well, how do I calculate the networks? Where are, all right, the 1024 networks? How can I see them? Well, first of all, we need to understand one thing. The first 2 octets we didn't mess around with. We messed around with 2 octets here. The third and the fourth. So, first of all, how does the third jump and how does the fourth jump? By increment number. So I'm jumping twice over here. You see, in my previous example, I'm just jumping with 1 octet. Same thing with class C. That was super easy. You're going to say, oh, wow, well, this is actually somehow difficult. No, it's not. Watch. So the first 2 octets, I don't mess with. I have to mess with the third and the fourth. So what I'm going to write over here, the jump start for the third and the fourth, right? So I always have start with a 0. So this one is going to go from 0 to 255, okay? And this one is going to be jumping by what, folks? By 64, okay? So for example, the first network is what over here? 172.16.0.0. Always you're going to have subnet 0. 0.0 is the first network. What is the next network? Watch this. Pay good attention over here. 0 dot what? 64. Then the third network is 0 dot what? I add 64. You see that? 128. That's what I get over here. So this 0 dot 128. Then I add another 64. 16, 0 dot what? 192. Then I go ahead. 172 is 16. 1.0. That's another network. 16, 1.64. Then 172. 16, right? 172 dot 16 dot what? Yes, 1.128. Then 172 dot 16 dot 1.192. And then I go to my next network, 172.16.2.0. See that? 172.16.2.64. Then 172.16.2.128. Then 172.16.2.192. Then I go ahead, 172, 16, 3.0, then 3.64, then 3.128, then 3.18. Do you see how the third octet is jumping? Is jumping by a 1. You see that? And each time it jumps by a 1, is jumping by a 4 networks for the last octet because my increment number is 64. So eventually it's going to reach this number, 254.0, right? So 2.0, 2.64, 2.128, 2.192, then 3.0, then 3.64, then 3.12, then 3.192, then 172.16.254.64, then 254.128, then 254.192. See that? Just like that. And then my last ones are 172, 16, 255.0, 255.64, 255.128, and then 255.192. That's my last network. Let's calculate. Okay. So let's calculate. So think about it for a moment. For each time I'm jumping by a 1, I'm jumping by 4s for the last octet. So each one of them has 4 networks, 4 networks, 4 networks. Multiplied by what? From 0, from 0, folks, 255. What? How many numbers do you count if you count from 0 to 255? 256. All right. 256 times what? Times 4. Let's go to our best friend, right? So 2 to the power of what? So look at this. What I'm looking for is, let's erase this. So I want to go back. So in other words, 4 times what? 0 to 255 is 256. So 256 times 4, right? 256 times what? Times 4 is what? What number do I get? Right? 1024. See that? 1024. So, Google is the best thing for when it comes up to what? To an actual calculator. Times 4 is 1024. That's what I get over here. This is perfect. That means I'm doing the right thing. All right. This is the right thing over here. And each one of them has how many hosts? Let's take a look at, let's say this network, 172.16.1.1 is the first host. Now the next network is 1.64. So what is the last host? 1.62. What is the broadcast? 1.63. See that? What's the number after 1.63? 1.64. So 1 dot what? 172. 16. 1.65 is the first host. 1 dot what? 126 is the last host. And then 1.127 is the what? The broadcast. See that? That's how I calculate this. That's how I get all this actual what? Information. All right. So how can I test this? Well, let's go to the Cisco packet tracer. All right. Let's see my Cisco packet tracer and see how I can plug in the actual numbers. So if I go over here and I say, you know what, let me put this number in 172.16, let's say dot one, dot let's say 0. All right. And this one I make it what? 255.192. I'm going to get an error message. This is the network ID. Okay, perfect. Nice. 172, 16, let's say 1.30, because 1.30, 30 falls in between this network, which is a 1.0 network. And I have to switch this to what? 255.192. So this is 1 dot, you see that? 30/26, that's a CIDR. And this will be 1.40. 172, 16.1.40, right? And this one will be what? 255.192. And the next one will be 1.70 and then 1.80, let's say. All right. 1.70 and 1.80. 172.16, 1.70. And this one is a 255.192. And this one is 1.80. Right. 172.16, 1.80. And this one will be a what? at 255.192. Close and close. All right, very good. So I go ahead and I'm gonna just move this a little bit over here, delete these, so this one and this one can talk to each other. This one and this one can talk to each other. This one and this one cannot. Look at this, failed, and this one cannot. They failed. So this tells us that we did the actual right work. All right. So what I want to show you next is this. Let's say we have 172.16, 0.0 slash 16, and I'm looking for 4,096 networks. Well, let's say 4,095 networks. All right. So we don't have exact. Okay, 172 at 16, right? At 0.0. That's what I'm getting over here. So what is the mask? 255, 255, 0.0. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Just like this. See that? That's how I actually have that. So how many bits do I borrow? First of all, I like to put my wild cards. 128, 64, 32, 16, 8, 4, 2, 1. Without this, you can't do anything, right? All right. So let me copy these and put them right here on the bottom. And then, how many bits do I borrow? 2 to the power what? Let's see. My previous example, when I said 2 to the n is 1,024. 2 to the 11 is what? 2,048. 2048? No. 2 to the 11 is 2048. 2 to the 12 is 4,096. That's the closest number. So I need to borrow 12 bits. All right. So 2 to the power 12, which equals to what? 4,096 networks. So I need to get 4,096 networks, but I'm looking for 4,095. I had to borrow 12 bits. Where are the 12 bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these are left for the host. How many bits left for the host? What is this, by the way? 255, 255, 255 dot what? 4 bits. Remember the value of the last one is 16 on the last one? So I add these up together, I get 240. So in other words, it's a 172.16, 0.0 slash what right now? How many bits? I'm using 8, 824 slash 28. Oh, it's a slash 28. So 4 bits left for the host. 2 to the power of what? 4 minus 2, which equals to 16 minus 2, which equals to what? 14 hosts per a network. See that? That's how much I'm getting. 14 hosts per network. Where are the networks? The side there is a slash 28, and it's a dot 240. Okay, very good. So my third octet is jumping by 1. My fourth octet this time is jumping by 16. Okay, so my first network is 16, 0.0. Then 172, 16. Then what I do? 0 dot what? What is it jumping by? 16. Okay. 172, 16, 0 dot what? 32. 172, 16, 0 dot what? 48. 172, 16, 0 dot what? 48 and 16 is what? 64. Then 172, 16, 0 dot what? 80. 16, 0 dot what? Right? 96, 0 dot 112. I'm doing good so far. You know why? Oh, I got the 128. That means I'm not messing around over here with the calculation. 0 dot what? 144. These are different networks, folks. 160, 0.176, 0 dot what? 192, 0 dot what? And 16 is what? 208. All right. And 16 is what? 224. And what? 16 is 240. And 16 0 dot what? 256. Do I put it? Okay. So look what I have over here. I have all of these. Okay. This is only for one, which means now, let me just show you over here. I don't want to waste a lot of ink. Okay. Ink is expensive. So this one is a what? A 1. This one is a 1. See that? This is the next networks, a 1. This one is a 1. All right. So the third octet is jumping by a 1 like the previous one. Okay, this is a 1. And I'm going to prove to you that all of this is correct in a moment. This is a 1, right? This is a 1. This is a 1. This is a 1. This is a 1. All right. All these are different networks, by the way. And this is a 1. Then eventually, what is the last range that I'm going to be looking at? This will be, it's going to reach what? Yes, 255. See this? 255. I'll do the calculations right now, folks. 255, 255, 255. See that? 255, 255, 255, 255, 255, 255. I'm sure you got tired of my voice. 255, 255. Right? See how it goes? I mean, subnetting is not difficult. You have to practice. You have to get yourself a piece of paper and a pen and do this again and again. Now watch this. Let me just prove myself here. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, right? Okay. Well, how many times multiplied by what? From 0 to 255 is what? 256. So what is 256 times 16? Let's take a look. 256 times what? 16. What do I get? 4,096. There you go. All right. So my calculation is good. So like let's focus on this one over here, on one of them. So this is a network ID. I cannot put it as an IP address. So if I put 1.16 with what mask? With a 240. 1.16 with a 240. 1.16 with a 240. A 255, not a 2. That's a network. I cannot, right? I cannot put it as an IP address, right? So let's focus here. This is a network ID. So what is the first host? 172.16. 1.17 is the first host. 172.16. 1.30 is the last host. And then 1.31 is what? The broadcast. Why the next network is this. And you see this? So if I have this network over here, 172.16, 1.33 is the first host. 16. 1.46 is the last host. And then 1. What? 47 is the broadcast. You see that? So each network comes with how many hosts? 16 hosts. I'm getting 14. 16 minus 2 is 14. So 2 to the 4 is 16 minus 2 is 14. So if you count from 17 to 30, that's 14. From 33 to 46, that's 14. So if one of them is, let's say, 20 and the other one is 30, one is 20, one is 30. So this is 20. Let's enter 16, 1.20. And I have to make sure this is a 255 dot what? Remember? 240. Right? So we're going back over here. The mask is 240. So I made one of them as 20. Right? This is 20. And let's say the other one is 30. 172.16, 1.30. 172.16, 1.30. And same thing. This is a 255.240. Then I go back and I use 40 and let's say 40 and 45. All right, for the 32 network, 40 and 45. This is 40, 16, 1.40. And I have to switch this 255.240. And the other one is 45. Let's see, 45. 116, 1.45, and then 255.240. All right, there we go. Okay, let's go ahead and do this. Envelope here and envelope here, successful. Envelope here and envelope here, successful. Envelope here and envelope here, failure. Different network, hello. All right, and there we go, right over here. This is failing. That's what I wanted to show you. So we did subnetting class C, we did subnetting class B, right? So I want to do some type of reverse engineering. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to do is reverse engineer a class B the way we did a class C, right, earlier. So watch this. For example, if I have 172.16, let's say .241.25, and let's say it's a slash at the beginning, let's say slash 19, right? How do I reverse engineer this? Well, if it's a slash 19, I know that 255 is 8 bits, 255 is 16 bits. I need three more bits, which is 128, watch this, plus 64 plus 32 dot what? Zero. So it's a 255. 255 dot 128 plus 64 is 192 plus 32 is 224 dot zero. So my jump start on the third octet is what? 32. So I would say 0, 32, 64, 96, 128, 160, 192, 224, 256. Where does the 241 fall under? It falls between 224 and 256. So what is the network ID of this number over here? It should be what? 172.16. Dot what? So it falls in between 224, right? Which is 241 and 256. So it's 224 at zero. That's the network it belongs to. So 224.1 is the first host, 255.254 is the last host, and 255.255 is the broadcast. For example, I have 172, right? Let's say dot 16, let's say 137 dot 243. And I'm going to have a slash, let's say 22. All right. So first of all, let me put the subnet mask. 255 is 8 bits. 255 is 16 bits. I need six more bits, which is 128 plus 64 plus 32 plus 16 plus what? Plus 8, 3, 4, 5. And there you go. Dot zero. All right. So that's how I get what? 255 dot 255 dot what? Dot 128 plus 64 is 192, 224, 240, 248, 252. That's my subnet mask. Okay, what is the jump start? Well, the jump start is 4, and I'm focusing on the third octet by jumping by 4. So it says 0, 4, 8, 12, 16, 20, 24. Eventually, it's going to reach 200, then 204, then 208, then 212, then 216, then 220, 224, right? 228, 232, 236, 240, 244, 248, 252, and the last number is what? 256. All right. Okay. Where does the number, like my main focus is what over here? The number 137. Where does it fall under? It's somewhere over here. All right. So, what I'm trying to show you is you jump, but you want to make sure whatever you're jumping that you're ending with 256. So if I say 4 times 5 is 100. So eventually it's going to reach 100. Then 104, then 108, then 112, then 116, then 120, then 124, then 128. So I'm doing good because I got 128, then 132, then 136, then 140. So where does 137 fall under? Between 136 and 140. So the network ID is what over here? Between 136 and 140. So I would say 172.16.136.0 is the network ID. 136.1 is the first host. 139.254 is the last host. 139.255 is the broadcast. All right. That's how I get this. Okay, let's do another one. 172 dot 16, let's say dot 125 dot, let's say 22. And I'm going to do a slash 28. How is that possible? Slash 28. Okay, 255 is 8 bits, 16 bits, 24 bits, four more. That's what? 40. All right. So where does 136 fall under? I have to treat this like a class C. 136 at 0. I did this on purpose. So the third one is jumping by a 1, and the last one is jumping by a what? By a 16. So I'm looking for 136.0. So guess what? The answer is 172.16. We don't mess with this. 136, I don't mess with this. It's a 255.0 is actually what? The network ID. So this is actually a network. That's how you reverse engineer a class. First of all, you put the subnet mask, and then you could see the jump start, and then you could see between which number and which number does it actually fall in between. All right. So, folks, the more you practice, the more you do this, you write it down, it becomes easier and easier for yourself to understand subnetting. So you really have to really practice, keep doing it again and again and again. right? Let's say, for example, I have another number over here. Okay, let's say 172.16, let's say dot 148 dot, let's say 56. All right, and let's say this is a slash 21. Okay, what is the mask? 255. 255, that's 16 bits. I need five more bits. 248.0. All right, so my wild number is the third octet. How did I get 248? 128 plus 64 plus 32 plus 16 plus 8. So the jump start is 8. Where does this number fall in between if I'm jumping by 8, right? So 8 times, let's say 20 is going to eventually 0, 8, 16, 24, 32. Eventually, like 8 times 20 is 160. What's the number before 160? If the jump start is what? 8, 152. Okay, before that, what number do I get? 152 minus 8 is what? 146. So guess what? 148 falls in between 146 and 152. So the network ID is 132.16.146.0. 146.1 is the first host, 151.254 is the last host, 151.255 is the broadcast. All right. So that's how I do the layout of the actual number. This is like the reverse engineering of a class B. So what I want to do next is uh, I want to go ahead and set up a technology, a switch with computers. And how does this actually work in real life? How do you apply the numbers with something called VLANs? All right. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at this subnetting a Class A network. As you see, we did C, B, and now we're looking at Class A. And of course, internally in a company, when we subnet a network, we're looking at the private network, such as for Class C, as you saw, 192.168, B, 172.16, and A, of course, the 10 network. When we deal with subnetting, we're dealing with VLSM, variable length subnet mask. When it's not subnetted, it's a full length subnet mask, right? And the CIDR, which is a slash 24, 25, 26, 27. So what I'm looking at is a 10.0.0.0. So by default is a slash 8, which means my network ID is 10.0.0.0. The subnet mask is 255.255.255.0 for class C. For B is 255.255.0.0. For A, it's 255.0.0.0. That's why it's a slash 8. So when I put my binaries here, when I convert to decimal, it's a 128, 64, 32, 16, 8, 4, 2, 1. So when I put all ones, all right, I get a what? A 255. When I put all zeros, what do I get? A 0. So this one is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. See that? Just like that. Let's say we are looking for, let's say, 30 networks, which is 30 subnets, right? That's what I'm looking for. 30 actual networks. All right. So what is the formula? 2 to the power of n is equal or greater than what? 30, all right? Networks. Okay. So when I borrow bits, I cannot borrow from the third or the fourth. I could start borrowing from the second octet. Remember, this is a class A. If it was a B, I start borrowing from the third. If it was a C, from the fourth. Okay. So these I don't touch. 3, 4, 6, 7, 8. But what? Okay, how many bits do I borrow? All right. So 2 to the power of what is equal or greater than 30? If I borrow 1 bit, 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. So I borrow 5 bits, right? Which this equals to what? 32 networks. And that's the closest number that I get to 30. Okay, so how many bits did I borrow? 1, 2, 3, 4, 5. And these stay as what? Zeros. They stay as zeros for the actual host. So how many bits for the host? 8 and 8 is 16, and 3 is 19. So 2 to the power of 19 minus 2 equals what? Right? That's what I'm looking for. So let me get online, all right, and say the following. I like to use Google as a calculator. 2 to the power of 19 minus 2 equals what? This is the number. Look at this. A lot of hosts, right? So let me just put this back right over here. And that's how many hosts I actually get. So 5, 2, 4, 2, 8, 6 hosts per a network. See that? So I get a lot of hosts over here. Let me just erase this. Okay, what is the value of the last bit that I borrowed from the second octet? It's an actual 8. So this one is 255 dot 128.64.32.16 plus 8 dot 0.0. You see that? So it's really 255 dot what? 128 and 64 is 192, 224, 240, 248 dot 0.0. So what does that mean? It's a 10, it's a 0, it's a 0, slash, how many bits? 8 and what? And 5 is 13. So now it's a slash what? 13 as so I have a slash 13 right here because I borrowed 5 bits, right? So 5 bits were actually borrowed. This is actually perfect. Okay, what is the value of the last bit that I actually borrowed, which is 5 bits? I borrowed the following. So if I go back over here, 1, 2, 3, 4, 5, right? Just like that. So the value is an 8, which means my jump start is an 8. I always have to start with subnet 0. 8 plus 8 is 16 plus 8 is 24, 32, 40, 48, 56, 64. Eventually, if I say 8 times 30 is going to reach what? 240, and then 248. And of course, the last one is 256. As long as I'm ending with 256, that means I'm doing all the work perfect. So what is my first network? 10,000. What is my second network? 10, watch this. 8, be careful, 0.0. What is my third network? 10.16.0.0. See, the second octet is what I'm filling in these increments up to the last one is what? 248. Okay, what's the next one? 10.24.0.0. Then 10 dot what? 32.0.0. Then 10 dot what? 40.0.0. Then 10 dot what? 48.0.0. Until what? I'm going to see 10 dot what? 240.0.0. And the last network will be 10 dot what? 248.0.0. So these are actually what? Network IDs, as long as I'm putting what subnet mask? This right here, 255.248.0.0. Okay, let's take a look at this network. What is the first host? The first host is 10 dot what? Dot 16.0.1. What is the last host? Well, the next network is 24.0.0. So the last host is 10.23.255.254. And the last host is always 2 before the next network. What is a broadcast? It's 1 before the next network, which is 10.23.255.255. What's the number after 10.233.255.255? Is 10.24.0.0. So I have hosts from 0.1 until what? 255.254. That's how I get this actual number right over here. Let's say this network over here. What is the first host? 10.40.0.1. What is the last host? Well, the next network is 48, so 10.47.255.254. And then the broadcast is 10 dot what? Dot 47.255.255. Just like that. So let me put a number. Let me see if I could put 10.16.0.0, right? 10.16.0.0. So I'm going to get myself a switch just like this, right? And I'm going to get 2 computers. Let's say 4. 1, 2, 3, 4. And let me get the actual cables. So this one connects to port 1. This one connects to port 2. And then let's say port 3 and port 4. See that? Just like this. Okay, so what I want to do is I want to go back over here and I can see that this is the actual subnet mask 255.248.0.0. All right. So I'm going to put 10.16.0. What? Dot 0. 10.16. Watch this. 10.16.0.0. It works, but I have to change this to what? 248.0.0. And now it's going to fail. Why? That's a network ID. Okay, let me try to put the broadcast, which is 10.23.255.255. So let me go back here. 10.23.255.255. See, if this shows like, oh, you're not subnetting. Well, now I'm going to tell it it's 248.0.0. And look at this. It's not working because I'm putting the actual broadcast. So I cannot put the network ID and I cannot put the broadcast. So I'm going to make one of them as, let's say, 10.23, let's say dot what. So what I'm going to be looking at over here, so I could go from 23 to which number over here, right? So 10.16. What I have over here, okay, this is actually 16, right? So the next one is 16.0.1 until 10.23. You see, because you always have to look at the one before that. All right. So let's say, for example, I had this one over here. So 10.8.0.1. What is the last dose? Well, the next one is 16. So 10 dot what? 15.255.254. And then the broadcast is 10 dot what? 15. You see that? Dot what? 255.255. It's very simple. Two before is the last host. One before is the broadcast. So let me give a number. This is the first one. Let's say 10.17.0.0. Watch this. 10.17 .0.0. And I'm going to make this as what? 248.0.0. This works. Okay, 1017.0.0. That belongs to which network, folks? The 16 network. And let's say the other one is 10.20.0.0. 10.20. Watch this. 10.20.0.0. And I have to switch this also to a 248.0.0. And then these two over here are going to be on a different network. I'm going to put them on the 40 network. So let's say 10.40.0.0. Watch this. 10.40.0.0. And of course, the mask is 248.0.0. Let's see, 10.40.0.0. Look at this. Look what I'm doing over here. Watch this. So I put 10.40.0.0. Watch this. And I'm putting the subnet mask as what? Look, look what it tells me. You can't. This is a network ID. Okay, so what I could do is 10 dot, let's say 40.0.1, and watch this now. Look at this, 248.0.0. Now it works. Okay, so I put 40.0.1 right on one of them, and let's say the other one is the last one this time. This time I'm using the first host and the last host, and then 10.47. Watch this. I'm gonna put the broadcast. Watch 10.47.255.255, and look at this here. 248.0.0. Doesn't work. So what I put is 10.247.255.254. This is fine. And then this one is what? 248.0.0. Just like that. So these two can talk to each other, and these two can talk to each other. So I put envelope here, success, perfect, beautiful. Envelope here. Okay, good. Failed. Let me try again and see what's happening over here. Okay, this one failed. Something is wrong. Let's take a look. 10.40.0.1, 10.40.0.1, and what is the other one? Let's open this one and see. 10. Look what I did. 247, and nobody said anything. 47. There you go. All right. Nice troubleshooting. Okay, let me go ahead and do this again. Envelope here and here, success. Let me try again, here and here, success. Then I put envelope here and here. It's going to fail. They're on different networks. Here and here is going to fail. Like to try it more than once because most of the time the first packet, folks, is lost. So in this case, I was able to get how many networks? 30 networks. All right, let's do another example. N.0.0.0. It's a /8. And let's say I'm looking for 120 networks. All right. So watch this. 10.0.0.0. 255.0.0.0. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say to myself, 2 to the power of what is equal or greater than 120. Okay. So what I'm going to do is the following. I cannot mess around with the first octet. This is a class A. I can start stealing bits from where? The second octet. So this stays the same, right? Now, how many bits do I need? 2 to the power of what equal greater than what? 120. 2 to the power of 5 is 32. 2 to the 6 is 64. 2 to the power of 7 equals what? 128 networks. Okay, so I borrowed 7 bits. 1, 2, 3, 4, 5, 6, 7, 8. And these are all what? Zeros? And these are all what? Zeros. Okay. How many bits are left for the host? 8 and 8 is 16, and 1 is 17. So 2 to the power of 17 minus 2 equals what? I'm going back to my best friend, which is Google. So I'm going to say 2, watch this, 2 to the 17. Then I'm going to say what? Minus 2 equals what? And it tells me the actual number. So 131,070. 131,070 hosts per a network. Now, why would I need a lot of hosts like this? I mean, as I said, the class A is most likely done for data centers, service providers. That's what I have over here. So that's how many hosts I have per a network. What is the value of the bits? Well, let me put my binaries again. 128, 64, 32, 16, 8, 4, 2, 1. All right. How many bits? 7? 1, 2, 3, 4, 5, 6, 7, 8. So the value of the last bit that I borrowed is a 2. So my jump start is a what, folks? Is a 2. 0, 2. Look at this. Then 4, then 6, then 8, then 10, then 12, then 14, then 16, then 18, until what number? Eventually it's going to reach what? 248, then 252, then 256. Okay, what is the actual network? 10 dot what? 0 dot 0 dot 0. My next network, 10 dot 2 dot 0 dot 0. Then 10 dot what? 4 dot 0 dot 0. Then 10 dot what? 6 dot 0 dot 0. Then 10 dot what? 8 dot 0 dot 0. Then it is eventually going to be 10 dot what? 248 dot 0 dot 0. Then 10 dot what? 252 dot 0 dot 0. Just like that. Okay, so let's focus on this one over here. What is the first host? 10 dot what? Dot 2 dot 0 dot 1. What is the last host? Well, the next network is 4 dot 0 dot 0. So 10 dot 3 dot 255 dot 254. The broadcast is 10 dot 3 dot 255 dot 255. Okay, but this network. So if I count 2.0.1 until 3.255.254, I'll get these holes, just like this one. If I count 8.0.1 until 15.255.254, I will get this number, 524 what? Thousand. Okay, so let me go back over here and take a look at number 6. So 10.6.0.1 is the first host. What is the last host? The next network is 10.8.0.0, so it's 10.7, right? .255.254, and then that's the last host, and the broadcast is 10.7.255.255, just like that. What is the subnet mask for all of them? Oh, okay, 255 dot what? 128, 64, 32, 16, 8, and 4, and what was the last one? 2. See that? Dot zero dot zero. So it's a 255 dot what? Dot 254 dot zero dot zero. So I could say it's a 10 dot zero dot zero dot zero slash how many bits? Well, 8 and 7 is 15. So this one is a slash 15. My CIDR is a slash 15. Okay, that's good. Let me go ahead and see if I could put 10 dot 2 dot zero dot zero as an IP address. 10 dot 2, watch this, 10.2.0.0. Okay, well, I need to change this to a 254.0.0. Doesn't work. Okay, well, if I put 10.2.0.1, that's the first host. And this one is a 254.0.0. This is fine. 10.2.0.1 is fine. That means it belongs to what? The 2 network. And I'll make the other one 10.3.255.254. 10.3.255.254. And I'm going to make this as a what? As a 254.0.0. See that? Okay, so these two should be able to talk to each other. And let me put something 6.0.1, right? 6.0.1. So I'm going to make this as 6.0.1, 10.6.0.1. And I need to change this to what? 248.0.0. Or no. Ah, there you go. Good. 254.0.0. Okay. Then I'm going to go to this one and put a last host. And my last host is going to be what? Let's say 7.255.254. 7.255.254. So 10.7.255.254. And of course, I'm going to update the mask, which is 254.0.0. Okay, let me go ahead and ping. So these two should be able to ping each other. And these two should be able to ping each other. But if I try from here to here, it doesn't work. And if I try again from here to here, it doesn't work. So now I know that this belongs to one network and this belongs to another network. That's what I wanted to show you in this lecture. In our next lecture, we're going to do more examples of subnetting a class A. So we'll see you folks later. Bye now. Everybody, welcome back. It's Mo again. Well, in this lecture, we're going to be looking at subnetting a class A. So we're going to be looking at other examples. So let's say we got 10.0.0.0 slash 8, all right? And let's say I'm actually looking for 256 networks. Let's see how this works out for us, right? So 10.0.0.0, 255.0.0.0, and I put 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so how does this work? 2 to the power of n is equal or greater than what? 256 networks. I'm looking for 256. All right. Okay. So watch this. 1, 2, 3, 4, 5, 6, 7, 8. How many bits do I have to borrow over here? Well, let's say 2 to the power of what? 8 is 2 to the 6. 2 to the 7 is 128. So I have to borrow 8 bits. And I get what? 256 networks. Look, this is kind of tricky. All right. So what does this tell me over here? 1, 2, 3, 4, 5, 6, 7, 8. And this is all what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is very simple. So it's a 255, 255, 00. So I am using a class A network, but it's a class C subnet mask. All right. So it's a 10.0.0.0 slash what? Slash 16, as you see over here. Now, how many bits I didn't touch? 16 bits. All right, no problem. 2 to the power of 16 minus 2, which equals to 65,534 hosts per a network. So what does this mean? I'm going to treat this class A as a class B network, except for what? I'm just manipulating the second octet. So watch this. What is a jump start? 1. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until what? 254, then 255. This is my first network. This is a second network, third network, fourth, fifth, sixth, seventh, eighth, ninth, 10th, until the last network itself. If you count from the number what? So I get 256 networks. 2 to the 8, 2 to the 7 is 128. 2 to the 8 is 256. So that's how many networks I could get. My last network is what? You see that? 255. So watch this. So for example, I'm jumping by one. So it's a 10 dot what? The second octet is being manipulated. So 00 is my first network. 1.0.0 is my next network. 2.0.0 is my third network. 3.0. See, 10.3.0.0, then 10.4.0.0, then 10.5.0.0. See that? Until what? Look at this. 10.4.0.0 and 10.255.0. I like this one because it's like, okay, it's a class A, but I'm using a class B subnet. So I'm going to treat it like a class B. In other words, the first two octets have to match for them to talk to each other. What does that mean? What is the first host over here? Well, the first host, remember, the first two don't change. So this is a 10.0.0.1 is the first host. Then 10 dot what? Dot zero dot what? What is the next network? One. Okay, well, the next network is one. So remember, it goes from 10.0.0.0. So this is the one that is getting manipulated, and I could mess around with the last two what? Octets. So the first host is 0.1, and the last host will be what? 255.254. And the broadcast is 0.255.255. See that? Now look at this one over here. So this one over here is 10.1, right? Dot 0.1 is the first host. 10.1.255.254 is the last host. Then 10.255.255 is the broadcast. Let's say this one over here. 10 dot what? 254 dot 0 dot what? Dot 1 is the first host. 10 dot 254 dot what? Dot 255 dot 254 is the last host. Then 10 dot what? 254 dot 255 dot 255 is the broadcast. So if I count from 0.1 until 255.254, I get 65,534 hosts per a network. So it's a CIDR as a slash 16. You treat this as a class B network. Let's verify. All right. So watch this. Let me go back over here and switch this to static. And I'm going to put 10.0.0.0. I can't. All right, watch this. Okay, how about this? 10.1.0.0. Okay, and I'm going to change this to a what? To a 25500. Look what happens. That's my network. Okay, well, all right, we understand. 0.1 is the first host, and I have to change this one to a what? See, it doesn't work. So let me just go ahead and change this. So 10.1.0.1, and then I'm going to change this to a what? A 255.0.0. All right. Now, let me close this out. So 10.1.0.1. So 10.1.0.1, and I'll put the last one, 10.1, 255.254. 10. So let me switch this. 10.1.255.254. And I have to switch this one to a 255.0.0. Okay, let me close and let me close. And let me use another network. Let's say the 254 network. So 254 dot 0.1. So 254 dot 0.1. 254 dot 0.1. And I'm going to change this to what? 255.0.0. And then this one is going to be what? 10.255, right? Dot what? So I am using the last one, right? So I'm using 254.0.1. So the last one is 254.255.254, right? So let's go ahead and take a look at that and see. So 10.254 dot what? 255.254, right? And let me make this 0.0. And there you go. Then okay, then okay. Let me delete this. So look at this, 10.1.0.1, 10.1.255.254, 10.254.0.1, and let's take a look at this one, 10.254.255.254. Okay, then I put envelope here, success. Okay, envelope here and here, success. But here and here, it's gonna fail, and here is gonna fail. There you go, it's failing. Okay, so I treat it like a class B. All right, let me give you another example. Let's say 10.0.0.0/8, and let's say we're looking for, let's say 1,024 networks. All right, let's see how this works out. 0.0.0, 255.0.0.0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Right? That's the way it is. 24 zeros. Okay. 2 to the power of what equals, all right, or greater than what? 1,024 networks. Okay, so look at this. If I borrow 8 bits, that's what? 2 to the 8 is what? 2 to the 7 is 128. 2 to the 8 is 256. 2 to the 9 is 512. 2 to the 10 is 1,024. So 10 bits. Okay, 10 bits. 2 to the power 10 minus 2. No, that's a network, right? So I get 1,024. There you go. Now, how many bits did I use? Let me put these down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There you go. So I used 10 bits. 8 plus 2 is what over here? 10. How many bits I didn't touch? 8 plus 6 is 14. To the what? 8 plus 6 is 14, minus 2, which is the network ID in the broadcast. And what is 2 to the 14? Let's go back online to Google, our best friend. All right? 2 to the 14 minus 2. Get 16,382. 16,000, imagine 382 hosts per a network. See that? Okay. What's the value here? 255, 255. That's what? 128 plus 64. All right. Look, dot zero. So 55.255.192.0. So what is CIDR? 10.0.0.0 slash what? Okay, 8 plus 2 is 10 plus 8 is what? So 8 and 8 is 16 and 2 is 18. So this is a slash 18. See that? Okay, what's the value of the last one that I borrowed on the second octet is a 1, it jumps by a 1, and the third octet jumps by a what? 64. So the second octet jumps by 1, the third octet jumps by 64. Look at this. So I'm going to say 0. I mean, I'm not going to do the 1 and the 2. What I'm going to do is this: 0, 64. Then what? Plus 64 is 128, 192, 256. All right. Okay. Well, these are only what? 4 networks. Well, where's the rest? I'm looking for 1024. So it's 10 dot 0 dot what? Watch this, folks. 0 dot 0. My next network, 10 dot what? 0 dot what? Dot 64 dot 0. Then 10 dot 0 dot what? 128 dot 0. Then 10 dot what? 0 dot what? 192 dot 0. See that? 4 for each. And then I go this: 10 dot 1 dot 0 dot 0. Then 10 dot 1 dot 64 dot 0. Then 10 dot 1 dot what? 128 dot 0. And then 10 dot 1 dot what? 192 dot 0. Okay. Then 10 dot 2 dot 0 dot 0. Then 10 dot 2 dot 64 dot 0. Then 10 dot 2 dot what? 128 dot 0. Then 10 dot 2 dot 192 dot 0. Until which number? Okay. Well, what's before 256 is 255. 10.255 dot 0 dot 0. 10.255 dot what? 64 dot 0. 10.255 dot what? 128 dot 0. Then 10 dot what? 255 dot 192 dot 0. So my last network is this right over here. And my first network is this. If I count, these are 4, and this jumps by 1 from the number 0 to 255 is 256. 256 times 4 is what? 1024. So this is perfect. So what is the first host, let's say, on this one? Well, every network gets how many hosts, right? So we said the calculation is what? 8 plus 6 is 14. So 2 to the power of 14 minus 2 equals to what? Remember? So it's what? 16,382. 16,382 what? Hosts per a network. A lot of hosts. All right. Okay. So watch this. So this one is 10.1.0.1. Okay. What is the last host? Well, the next one is 1.64.0. So this one is 10 dot what? Dot 1, right? Still, I'm using 1 dot what over here? 63.254. 10 dot 1 dot what? 63.255 is a broadcast, right? You see that? 63.255 is a broadcast. Okay, let's say this one over here. 10 dot what? Dot 2 dot what? 64. Remember, this is 64. Let's say dot 1. The last host is 10 dot 2 dot what? What? What number over here? The next one is 128, right? If the next one is 128, so 127.254. And then 10.2.127 dot what? 255. There you go. See, just like that, every network gets 16,300 and what, 82. So if you count from 64.1 until 127.254, you get this actual number. Okay, let me try and put this as an IP address. So I'm going to go back 10.1.0.0, 10.1.0.0, and this one 255 dot what, 192.0. Doesn't work. It's the network. All right. So look what I'm going to do over here. 10.1.0.1, 10.1.0.1, 10.1.0.1. And I'm going to change this to what? 255 dot what? 192.0. Then I'm going to close. So 10.1.0.1. Okay, good. What is the next one? 10.1.63.254. 10.1.63.254. 10.1.63.254, right? So that's the number I'm putting. And of course, I have to put 255.192.0. All right. Okay. And then there you go. This one, 64.1, 64.1. Let's put that number, 10.1.64.1. Now I'm going to update the mask, 255.192.0. All right. 10.1.64.1 and 255.255.192.0. There you go. So 10.1.64 dot 1. I'm using this one over here, the one I didn't do. So the next one is 10.1 what? What's the next one? 127.254. 10.1, 127.254. So this is 10.1. See this? This is good. 10.1. Let me switch this. 10.1. Dot what? 255.251. And then this 255.192.0. There we go. All right. So let's take a look and see. Let me put envelope here and here. Envelope here and here. You see this? Okay. It failed. Why? There are different networks. How about here and here? Let's see. Did I do something wrong? Did you guys see any mistakes? Right? Let's take a look. What's the number over here? 10.164.1. Okay. 10.164.1. And this one is 10.1. 63. You guys didn't say anything. Okay, good. 63.254. Now watch this. Oops. 10.163.254. Already in use. Where is it used? Where? You see, look, isn't this amazing? The Cisco packet tracer does find mistakes for you. So look at this one. This is 10.1. Look at this. This is 10.1, right? Let me just see. Okay. And look at this one over here. 10.1. Ah. Oh, look. Okay, 10.1. Okay, this is 64. So this one is what? 127. Dot 254. All right. So this one is a 255.192.0. Now it's going to be fine. Watch this. You guys didn't say anything. Okay, so I'm going to put the envelope right over here and right over here. Success. Envelope right over here and right over here. Success. So these two should be able to what? Ping each other. So what's happening over here? 10.1.0.1. And what's this one? 10.1, 63. Okay, the subnet mask is good. 10.1.0.1 and 10.163.254. What's the problem, guys? What is the problem? 10.163.254. I don't see a problem here. 10.1.0.1 slash 18, 10.1.063.254 slash 18. Let me delete these and try again. Here and here. Successful. Okay. Here and here. Successful. Okay. Here and here. Failed. All right. Look, here and here. Failed. Okay. So this is good. See, that's a good thing about troubleshooting. It's always a number. What I'm trying to show you is it's always a number. It's like my cable's physically connected, but all of a sudden, why they cannot talk? Okay, let me check the IP again. Let me take a look and see troubleshooting. So we'll see you folks in our next section where we're going to reverse the engineering of a Class A. So we'll see you folks soon. Bye now. Everybody, welcome back. In this lecture, we're going to be looking at is the reverse engineering of a Class A. And after this, we're going to do a lot of quizzes until you actually master subnetting. So it's going to be a lot of good work to do. So let's take a look at the first one. This is a Class A. I don't care what the slash is. Let me put the subnet mask. Let's put it in our head. 255 is 8 bits. 255 is 16 bits. I need 3 more bits, right? 128, 64, 32. I add them up together. I get 224. That's 0. So my jump start is 32. 0, 32, 64, 96, 128, right? And then 32, 160. And then what? 192. All right. Okay. What is the wild card over here? The third octet. Where does it fall under? Between 160 and 192. So if this is the host address, what is the network ID? Well, the network ID is what? 24.191. Dot what? 160.0. The next network is 192.0, right? So what is the broadcast? 24.191, right? Dot 191. Dot what? 255 is the broadcast. See that? I just reversed engineered a Class A network. Let's take a look at the next one. Look at this one over here. Okay, what's the mask? 255. 255. Dot what? 255, right? Dot what? How many bits? 6 bits, right? 6 bits that I have, which are what? 128 plus 64, 32, 16, 84. I get 252, right? Okay, what is the wild card? The last number, which is 133. Now, what is my jump start? How did I get 252? The value of the last bit was an actual what? 4. So my jump start is a 4. 0, all right? 4, 8, 12, 16, right? And so on until it reaches what number? I'm looking for which number over here? I'm looking for the actual number that is what? This is a 133. So I'm multiplying by 4. It's going to eventually reach 120, 124, 128, then 132, then 136. So 133 falls in between 132 and 136. So watch this. What is the network ID? 52 dot 6 dot what? 91 dot what? Dot 132. What is the broadcast? 52 dot 6 dot what? 91 dot what? 135. Just like that. This is just reverse engineering of a class A. In our next section, we're going to be looking at a lot of quizzes, how to subnet, how to find the host, the broadcast, the network, the mask, and all that. So we're going to be mastering the subnetting itself. So we'll see you folks in our next section. Bye now. All right.